Welcome to Lesson 3 of Swift Memory Management with Bob the Developer. In Chapter 3, learning about closure, you discovered the unique behavior of a closure block, and that you noticed that closures are also reference type like classes. So far, we've learned that reference type may lead to retain cycle. In this lesson, you will first going to learn how to create a retain cycle using a closure block, and then solve it using weak as well as capital list. So let's get started. Welcome to Learn Swift with Bob Memory Management. Today let's talk about retain cycle that may occur within closure block. Okay, so here's a problem statement. How to use capital list to prevent retain cycle in closures. So as you know, closures are what? We talked about in Chapter 3. They are reference types. So when it comes to reference type, that means it's all about pointing at each other. So when it comes to pointing at each other, we have to acknowledge ARC, and also there might be a bad stuff such as retain cycle. And also you will talk about when to use unknown. What the heck is unknown and why do we use them in the first place and when to use it. Okay, well, before we move on, you might be wondering, hey, which one should be weak? So within the delegate pattern, it doesn't matter whether it's delegate or just if there are a lot of objects. And you might wonder, hey, I want to prevent retain cycle, but you don't know exactly which one should be weak. So let's talk about it. So right now, sending VC contains this property has a weak reference to this receiving VC. Okay, so you might wonder, okay, let's flip this. Okay, let's see. Let's try to flip this. So the color becomes this one, and this one becomes the strong. Okay, so now let's take a look at it. Here is the funny part. Now, how many reference does sending VC has? How many? 0. So what does that mean? It will be deallocated right after. So right now, of course, it should be weak, and then this one should be normal, right? And when you have a weak reference from sending VC to sending VC object, and this one has 0 reference because the weak doesn't count, so it will be deallocated. So what's the point? Right now, if you think about it, it doesn't. This is a delegator. This is like a UI table view. It will be deallocated right away. So there's no point of. So you know when to use which one to weak and which one to weak and which one. If you are a little confused which one to be weak, then all I ask you is just draw a diagram and see what's up. And again, sending VC, which is delegator, the property of the delegator should be weak. I don't think I have to explain, right? The other way simply doesn't work out. Okay, cool. So just wanted to make sure we are on the same page. So now let's go back. You know when to use which one should weak var. If you don't know, just draw a diagram. Okay, so now let's try to find out a possible retain cycle within closures, and then later fix it with capital list. We talked about a capital list. We're going to come back to it and see what's up. So first of all, let's design a class that potentially leads you to a retain cycle. We have a Bob class closure block, which is an optional type. Okay, again, every type can be optional. Okay, just like string, just like we talked about it a lot. But I want to initialize this closure property. Yeah. Let's call it like that, and then Bob closure equals, and you want to print something. Let's say print Bob the developer. Bob the developer right there. Boom. All right. So now let's try to call this closure block. How to do that? So first of all, what you do is you want to create this Bob class object, and the Bob class small letter. This is instant. That has a reference to a Bob class object, and then now Bob class object, Bob class dot Bob closure, and then in order to execute, you do this one like that. But right now, of course, it's gonna be you have to unwrap it because, as you know, you cannot use it by itself. This is the optional type, so you have to unwrap it. You may use it this way, okay, like unwrap it and then run this closure block. Or you may unwrap it using this way and then doing this like that. Okay, so unwrap the closure block, closure type, and then execute the closure after. Okay, so you get the point. Okay, so now let's take a look at it. What if you now set Bob class as nil? What do you think is going to happen? Let's see what happens. On the bottom, let's see. Come on, next code. Bob the developer. Alright, we forgot to have the init method right there. Print Bob class. Gone, let's put it that way. Okay. So now, if you take a look at it, Bob class gone. It's being deallocated right away. Well, let's go to this diagram and show you what's happening. So now we have a Bob class instance that has a reference to this Bob class object, contains two properties, Bob closure and Bob name. But if you think about it, this Bob closure has a reference to what? This closure block. Looks pretty interesting, right? This closure block is actually outside of this Bob class object. It has distinct memory locations that's pretty that way. If you are not coming from C++, C, those languages, it might give you a little confusing ideas. But all I'm asking you is think like this box is your RAM. All right. This Bob class object contains this particular object like space like this, but this closure block also has its own space. And all you're doing is this Bob class property has a reference to this closure block. All right, they're separate away. They're separate. Okay, that's what we call reference type. So when it comes to Bob class instant has a reference to this Bob class object, just like that, Bob closure has a reference to this closure object. Okay. A lot of people are confused by that. If I don't make a diagram like this, people will get confused. But I just want to make sure we are on the same page, and I think this is a very good idea, good way to visualize what the heck's going on. Okay. So now what happened is how many reference count does this closure block have? 1, right? So now if you break the reference here, what's happening is right there, boom. Not this one. This one, the Bob. Right now you broke the relationship. This one broke the relationship. This Bob class get deallocated, and what happens is this one will also get deallocated because of this reference will be broken because it doesn't make sense to have a reference from something that doesn't exist, right? This will be broken, and because this closure block has 0 reference, it will be deallocated as well. Okay, cool. But we cannot know whether this closure block has been deallocated or not. Unlike this class contains the init method, but this closure block doesn't contain its own init method. So there's no way for you to know. But however, when it comes to Xcode 8 or 9, it provides an app called Instrument, which allows you to detect retain cycle within closure blocks. So if you want to know more about that, find more about Instrument. Okay, in this course, I'm not going to talk about it. Just a whole new chapter. Just wanted to make sure you guys can find the retain cycle within closures. Okay, so let's talk about I forgot about it. So now everything works fine, but what you want to do now is you want to make a reference retain cycle and see how to do it. Well, all you want to do is, what if you do this way, self dot name here. Okay, so now you have a Bob the developer. It's going to print Bob the developer, but here's a problem. It's not being deallocated. Why is that so? Well, now this closure block has a reference to self. Well, let's take a look at this. So now this closure block, you broke the relationship. However, this closure block has a self.name. Where does self come from? Well, you have to reference this object, right, about the class self, in order to have a property name. So they're referencing each other. As you know, when they're referencing each other, there's a retain cycle, and this is bad stuff. Right, you don't want this from happening. This is bad, yeah. So what do you do now? Well, you know what to do. All you want to do is you want to have a weak reference coming from here. You want to do something like this. Let's see, change the border color to what was the color we used last time? Something like this. You want to have a reference coming from here. So what happened is now Bob class is zero reference, will be deallocated, and then this closure block will be also deallocated because it will be this relationship were broken. So how to do that? Well, by the way, let's go before I talk about removing the retain cycle. Why? So now here in this case, you're not allowed to just use name by itself. But outside of closure block, you may use just print name. For example, when you have a just normal like that, you may use name equals Bob Lee. Like, you're able to do that, okay? But here it's gonna complain the fact that here it's gonna complain you have to use self. You have to use self within closure block like this. Well, this is a way for Swift engineers design this language, saying that, hey, when you have self.name, you are referring to self.name self here. So be careful, because later you might have retain cycle. Okay, this is a way for Swift engineers to tell developers, hey, you are accessing the property of self within the closure block. So make sure check out possible retain cycle in the future if you're using classes. Okay, so it's like a warning sign self. Okay, so that's why you have to use self, and that's the rule within closure block. It's like a declarative way for you to saying that this is quite dangerous. All right, this is not a good thing. So anyway, so now let's go back and then see how we can do this kind of stuff to make sure we deallocate the Bob class object as well as the closure block. And how do we have this weak reference? Again, you might wonder, can we have you don't know which one should be weak? Well, we can try to do like flip it like this, but it doesn't make sense, as you know. Why is that so? Because this closure block will be deallocated right away, because as you know, there's no reference at all. So when you have this closure block, it will be deallocated right away. So it doesn't make sense to have this kind of relationship. We go back here, and then this closure has a weak reference to the Bob class. Okay? Okay, let's go back. So all we have to do is, here's a magic part. We're going to use something called, we're going to use the array block that we learned last time with the capture list, and you're going to call it weak self. Okay? And then let's use in, but it's going to complain. Why is that so? It's going to ask you to have this right there. Self suddenly has become optional type. Well, I'm going to walk you through, see why is this happening. So now when you do this kind of weak self, what's happening is this closure block now has a captured self, the object, with what do you call that? With no reference type. It's like with no reference. It simply have an unknown reference to a Bob class. Okay. So it does not. So yeah, I think this should make sense. Like there's this kind of relationship right now going on, but the problem is there all of a sudden it becomes self-optional type. Why is that happening? Well, it might be difficult for me to explain to you, but let's go back to the principle when it comes to weak. In the last lesson we talked about it. Weak can be what? It has to be optional, and because you never know. For example, this object, right, might be deallocated by what? Might be deallocated by this Bob class. And the self, when you have a reference to this Bob class object, if the Bob class object is deallocated, what happens is the self has to be nil. And when it comes to weak, you want to have it nil. Because if you don't have nil, what's going to happen is you're going to have a big problem. It's where is self? It's going to be, if it's just normal type, you already know that you're not allowed to have nil value for normal type. So you have to be optional for weak, okay? So that's why automatically self, when you have a weak reference here, when you have a weak something reference, it automatically becomes optional type, okay? Am I making sense? If I'm not making sense, well, I recommend you to go back to the previous lesson. I talked about it explicitly, why weak has to be optional type, why it can be nil, because it can be deallocated by some other relationship at any time. If you are confused by that, you can ask me a question on Slack, Udemy, whatever. Okay, but I think I made myself clear. If I have not, then yeah, you can contact me. So it automatically becomes optional. So you have to use what? Either guard statement like this, like that. First we'll use guard statement right there. Okay, and then if there's an object, you can do something like object print Bob the developer. Okay, so now let's go back here. Bob class equals nil, Bob class gone. That's what you want to do. Okay, it's amazing, amazing. But here's the thing. So now here's a little difference. Now you can also use as an unknown here. But you might wonder, what the heck is unknown? Well, first of all, let's use unknown. And then unknown, you don't have to use, it returns normal type. And then you can just self dot like that. So when it comes to unknown reference, there's no optional, and just provides a normal type, just like this. Just like that. So self dot name, the Bob developer. Well, when it comes to unknown, okay, I'm going to explain more in detail, but all I want to say is when it comes to unknown, the biggest difference is that, well, just like weak, unknown reference does not increase the reference count. So right now, Bob class is only one reference count coming from Bob class, okay? But when it comes to unknown, it's telling you that this Bob class, this closure block is 100% sure that this Bob class will exist, all right? But as you know, it may not be the case, because this Bob class might be deallocated by this Bob class instance. When you set the relationship as nil, just like that, and then when you call this closure block, you're gonna have a runtime error. Why is that so? Because now it will be deallocated like that instantly, and then you're getting this error. It's like a very analogous to forced unwrapping. Okay, if you try to get the unwraps that the value is nil, you're gonna have runtime error. You're gonna have to error when you access the property, right? Just like that. When it comes unknown, you're gonna have that runtime error. Runtime error means you're using your app and suddenly app crashes. Okay, you don't want that happening. So for the safety, if you're 100% sure that this self will not be deallocated, right? You can use unknown, but most of the time it's recommended that you use weak, because you don't want to have, just in case, right? This is safer, because you never know whether Bob class can be deallocated, will be deallocated or not. You don't want to just trust your gut feeling. Make sure you use weak, okay? But just wanted to give you one more example when it comes to credit card. I know this example is not inadequate for using unknown, so I have made another example for you to understand how unknown can be used. So what I'm going to use, I'm going to create a relationship between card and owner and credit card. So as you know, okay, first of all, as you know, the owner may contain credit card, so it's optional type, but credit card, on the other hand, has to have what? It has to have owner. The owner may own credit card, but a person may own a credit card, but the credit card must contain the name of a person, right? Yeah, call it owner, and then contains the credit card property. So I'm gonna create this credit card relationship. So now, credit card right there, and then this credit card also contains a property called let owner. But here I'm gonna call it unknown let owner, and then in it, you're gonna enter the owner. You're gonna initialize the owner. You have to enter the owner and owner that enter owner right there. Okay, and we're gonna have a deinit method on the left side. Deinit print card gone. Okay, cool. So I know it may not make sense right now. I'm gonna walk you through very slowly. What is the problem? Cannot assign immutable expression to owner type. Interesting. Oh, it's because we're assigning to a type. We have to assign to this property. Okay, cool. So now let's initialize it. Create a couple instances. First of all, let's create Bob. All right, owner, but owner, as you know, may contain credit card, but here and then we create my card, credit card. And you have to enter owner, right? When it comes to credit card, contains the init method, and as you know, the owner is not an optional type. It's what do you call that? This is a normal type, so you have to get the normal value. That means you have to force unwrapping. I mean, this is not the best way to go about, but for the sake of simplicity, for understanding, you have to force unwrap or unwrap whether safely, and then you enter the value of Bob. Okay. And now let's have a relationship. Bob.credit card equals my card. And then, okay, this may not make sense right now, but let's go take a look at the diagram right here. See what the heck's going on. So right now the Bob instance has a, what do you call it, reference to owner. And the owner contains a property called card. And the card has references credit card object. And then my card has a reference to credit card object. And then yeah, so it's all good. But now let's take a look at it. Let's try to deallocate. So now let's try to deallocate Bob equals nil. So what you're trying to do, you're going to try to break the relationship like that. Break the relationship like that. Okay. And then, okay, now let's take a look at it. Let's look at the Bob owner is gone. Yeah, owner is gone. Why is that? So because now owner has what? Zero reference. It's going to be deallocated right away. It will be deallocated. So what does that mean? It's going to be deallocated. And then this will be also gone. And then now you set the my credit card 0. The credit card will be also deallocated. Let's call it my card equals nil. You cannot do that because, well, because my card is not 0. You cannot deallocate my card because this is non-optional type. But what I wanted to say is, it's not about, or we all know how to deallocate stuff, right? We all know how to deallocate stuff. But here's the problem. What if, okay? What if, let's go back here, Bob equals nil. What if you do something like this? My car.owner. So now what you're trying to do is the owner has been deallocated like that, right? And then what you're trying to do is this credit card contains is what? Unknown reference, right? This unknown has a reference to my owner. This thing has been deallocated, but what's happening is the credit card let owner is trying to access this owner property. So what's happening? My card.owner, it's going to crash. It's saying the error execution was interrupted. Reason signals. I don't know. You cannot read the error, but let's take a look at what the error message says. The process has been left. All right, you cannot read it. All it's saying is, where is the owner? All right, that's what's asking. Where is the owner? Because now unknown means it has a what? It must have the owner. What do you call it? Object you're referencing. You must have it. It cannot be, the relationship cannot be broken. But now the owner has been deallocated by Bob. And what's happening? It's gonna crash. Okay. So you don't want this from happening. So I don't recommend you guys to use unknown, just for the sake of, it's just like forced unwrapping. You don't want to use forced unwrapping no matter what. I mean, there are cases that use forced unwrapping by default if you're 100% sure, but most of the time, yeah, don't use unknown. The reason I want to make this example is not to, is to show you that unknown can be dangerous because you never know. Things can get deallocated at any time. So I don't recommend you guys to use it. Use weak. Use weak. Okay. Yeah, there's a couple lines you might have to do unwrapping, but it's safer. It's better. And yeah, you don't want that crash. It's all right. See you guys in the next lesson. This lesson was a little tough and might be long. If you have any questions, comment below. I'll be right there for you guys. And if you have any questions, yeah, repeat myself. But you like the background? By the way, it's new. Yeah, I got this new lights. Boom. Let us recap a little bit. Like classes, closures are reference types, so we have to be aware of possible retain cycle in the future. To prevent one from happening, you may use capture list to set the reference from closure block to self or the object as either weak or unknown. Again, please remember that when you have a weak reference, it also has to be optional value as well, because you know that self can be deallocated by something else. If you use unknown, however, that closure block must have a reference to that object all the time. That's why when you have, there's no question mark. But if self or any object is deallocated before and this closure block try to access it, you're gonna have a runtime error, and it's not good. But of course, we don't live in a black and white world. If you're 100%, 110% sure that object will never be deallocated, well, feel free to use unknown. In the next lesson, you will learn one of the most dreaded topics of all time, learning about escaping as well as auto closures. See you in the next lesson.